Hello, in this video I show you how I make Estop function safety door using a safe Siemens PLC with Profi Safe adapters and also TIA portal. Okay, um, I do have a couple Estops already, but let's start with the one from the beginning. So let's assume on one of our modules on the KF22 channel 0 we have a E-stop. So first of all we will go back to the configuration. I'm going to make this really short because there is already a video about that. So on the channel 0 we will be using 1 out of 2 evaluation equivalent with the supply voltage 0 and 4 according to channel 0 and 4, and we need 2 channels because in order to reach a safe E-stop function you need always redundancy with 2 channels, so that's why we use 0 and 4, and they are both activated. Manual failure acknowledgement and 1 out of 2 equivalent. All right, and we will be using the inputs 600 0 and 600 4. So therefore I make a tag E stop. Let's say oops. Hang on, I have to go offline. You cannot change tag names online. So let's say E stop KF22 channel 1, and copy that and put it on the 4. You will not see that anyway, but I'm gonna make it anyway, just so we have a clean numbering. Okay, so as you know from the other videos, if you use 2 channel equivalent you read only 1 channel in the PLC program. So in order to do that we go back to the main safety program in an empty network, and on the left side here you have the tab instructions, and in the instruction tab there is also a folder that says safety functions, and in the safety function there's an E-stop included. So you can drag and drop this over to here, and we make a multi-instance and we call it just KF22 and click OK. If we make a multi-instance we don't make new data blocks here. Where are they? They are somewhere here. But we make the instances right in the existing block where we program our safety. So we should finding it right here. So this is the instance for the E-stop, and there you can see also the individual used addresses, bits and bytes and inputs and timers and so on. This is all in here. And if I would not do that, we would have it somewhere here on the side on LRP safe. It would just create another safety block right in this LPR section here. Okay, so this being explained, we have the E-stop right here. On the first bit, I think if we hover over the function, we will see the emergency stop. So I forgot the tag name. Sorry about that, Estop KF22. So I might as well copy that and put it in here. And if you don't copy it, you can always, let's delete it again. And if you write it again, you just start with E dash, and then you will have everything. Now E stop. Oh, that's the instance. We don't have the input, so we just copy it. There will be another video about how to name the tags correctly, but this will be a whole different topic, so we're not gonna go into that. Okay, so this is the safe channel from the input, and then here the next thing is, does the Estop need an acknowledgement? An Estop basically always needs an acknowledgement according to IEC. I will probably write that down somewhere. I can never remember all these IEC normative stuff, and so we leave this as a true, and then we need an acknowledge input, and we just use the basic acknowledge that we always use, also just to make it easier. And like I said, the program structure will be made in a later video. All right, and then we have an output here which says that the Estop is okay. So for this output, in order to process that later on, I will create a new data block. Create new block, add new block, data block, and that needs to be a safe function, and it's a global data block, and we want to make a manual number. And since everything is used in the 3000 numbers, we will just go ahead and name it 3001, because I have already one created here, but I didn't want to use that. I just wanted to start with a new one. All right, so what I did not do is give it a name. You can just, so I did not give it a name, so just give it a name here by clicking on it and call it safe Estop door. So just give it a name which is relating to the function, and then we'll put a new bit in there, a static bit that says Estop KF22 OK. So hit enter, copy it. Or no, we don't have to copy it in order to make this very easy, so you don't have to remember all the names. There is a very easy way to do that. We split the view, and then you can just go ahead and drag and drop this 2 here if I'm right. Yes, there it is. See, now you get the whole structure of this bit with the DB name, the data block name, and the bit name. Okay, so let's unsplit that again, and there we go. So this is pretty much the easiest way. There is a delay that will be for different stop categories. I mean, usually you got a stop category 0, which stop category 1, I'm sorry, which turns the power off to any actors that are necessary to be switched off by the Estop. And then there is also a time delay where you can say, let's say you got a like a servo axis or a motor that need to stop in a controlled way. That way you can make a delay in here. Okay, so let's just go with the immediate stop, and we make another network. Add a network. Make it normally open contact, and copy this to here, and then we have I created a bit already that says something with output Estop. Output Estop, there it is. All right. So now if the Estop is okay, this will switch on, and the output will also switch on, and we have the output going to a relay, but I will show that later on. Okay, so let's download. I'm gonna do everything live with a live setup. I can just real quick show you that. It's a little bit messy because there are quite a bit of wires and switches on it already. So we have the controller, the CPU, a 1515S F, sorry, with 2 input cards, 3 output cards, and we have 4 ET200 nodes for each corner of the press, a power supply, some terminals, a switch where we have all the nodes connected, and a power supply and a couple of fuses. So, and finish. All right, so actually I gotta find my E-stop now because I got 8 E-stops on the whole thing. So now we go online. Put on the glasses that we can monitor, and we have a true status, and if I push the E-stop it goes false, and if I reset it, it goes true, but the output is still false because we have true on the acknowledge necessary. So we do need to acknowledge this E-stop, and if we acknowledge it, the Q output will turn true. All right, and so does the output, the physical output on our card, and so does not the relay. Why is my output not on? There's something else. Of course the output is not on because I am writing it already on here. So this is a big mistake. This is pretty much a beginner mistake, but I've been messing with the program so much. So what I'm doing here, what I'm doing wrong here is I write an output here, which should actually set the output high, but the output is still low, and it's because of I'm setting it to 0 here, so I need to delete actually this output because this isn't gonna work like that. So let's delete that. I think that's a pretty good example for basic common mistakes that some programmer make, that they write an output twice, or even if you got a flag like an M flag, you should not write it twice because it's always being the last in the cycle. The last status is always the active status. Output is off because we do not have the acknowledgement. Now the output is on, and now we can see the physical output on this LED, and this LED goes to a nice little relay which is also on. You have to excuse the mess here. I'm just trying to show as much as possible. And if I push the stop, it's off. Turn the stop on. Acknowledge it, and we do have a light. All right, so now I just told you that we have 4 corners. So let's say we make the other corners also. In order to do that, we go over to the Datablock and we call it Estop KF12. Okay. And we copy that and make a 32 and also a 42. All right, so in this section I do have to make a small break. Somebody's calling, I'll be right back. Sorry for that. Okay, so we do have all our data block bits set, so let's assign these to the Estop blocks. So therefore we split our screen again and we say, now I'm not sure which is what. This is the KF22 and this is the KF32 that here, and we have the 42 and the last one is the 12. Okay, so let's go ahead and unsplit the screen. So now we have all 4 bits set. So now in order to do a professional programming, we do have to move this network below the last call, because otherwise we would need 2 PLC cycles in order to write the output, and we don't want to do that. So let's move that network down to the network 6. Let's just real quick give that a name. Estop KF22. Copy, paste 32, paste. Oh, I make twice. I made 232. 32. Why do I have 232? And 12. So what's missing? The 42 is missing. This one here is the 42. There we go. Let's change that real quick. There we go. Okay. So now we close the networks. We have a little bit of an overview on what we're doing. So take this network and we should be able to just drag and drop this down to right here, if this is correct. Yes, it is. So now we have all 4 E-stops, and then let's just go ahead and make another 3 normally open, and just copy that, or let's make it just nice and neat and say this is the 12, copy paste, this is the 22, and this is the 32, and this is the 42. Download. So while it downloads, using this Datablock here for the safety also enables us to use these bits globally and not only local on this one program block. So later on, when the program grows larger, we can always use these bits from the data block because they are global and it's better to do it that way. All right, so let's put on the glasses and see what happened. If we push the acknowledge, we should have only one. I know we have all. Why do we not have the other e-stops? Because very simple, because I did not put the acknowledge bit in there. So you have to put the acknowledge bit in there, of course, otherwise this whole thing will not work. All right. Now acknowledge, and now we have all four outputs on, all four signals on, and also the relay is on, and we are good. So this was a pretty long video. I know in the beginning of the video I said it's gonna be with the safety doors also, but I think the basic video is gonna get too long, and the safety doors are pretty much the same. Or let's just, we can make one. Just make, I'm gonna make one. Okay, therefore we put a network after the e-stop. I'm gonna make only one door, so that's gonna be fast. So after the e-stop, go over to the left side to the safety instructions again and take a safety door. Just move it over and call it safety door. This is the KF, also the KF 12. And we make a multi-instance with it, that we don't have all the big data block mess, and there we go. All right, so we need two inputs. We need a QPad, which we don't really need. This is, so the QPad, if you want to know what it is, just click on the instruction, push F1, and there is an explanation for it in this help file. So whenever you want to know something, just click on the instruction, push F1, wait for this circle to stop. So here is the explanation. I will not go through that. This is just some double check with the QPad signals from the physical input, which I will skip right now. So we have two inputs. You can either use both of them. You have to make sure that your door is also used with two channel. So I used the KF12 for it, which is this one here. I used the next two channels, which are channel 1 and 5. So channel 1 is 0 and 4, and the channel 2 of this board is 1 and 5, and this is also 1 out of 2 equivalent. And you have to make sure that this is really done like that. And also we can just give it a name real quick, where we say, what do we say, 1 and 5. So safety door KF12 CH1, and with this one we say CH2. And because I'm lazy, I copy it. And as we know, we only write one bit to the program, to the actual program, so we put both inputs with the same name. If you have two individual sensors on a door, where you have to make sure hardware side that you have really a safe two-channel operation, you can also go ahead and make the channel configuration 1 out of 1 here with the equivalent 1 out of 1. But then you have to make a risk assessment, which brings you to the right way in order to get your safety evaluation correctly. That's why I'm going to leave it like this and go back to the qubit we don't need. The open necessary, this is some people, they say in order to get an acknowledge, the door needs to be opened. That way it's made sure that the area behind the door, behind the safety fence, is clear, that there is nobody in there. So you have to go physically to the door, open it, visibly check if the area is free, and then you can reset the gate. So I make this false for now, and the acknowledge necessary we will make true, and here we will make also the I550.0 the whole acknowledge. I mean, the acknowledge for a door, you must also, according to your risk assessment, the acknowledge for the door should always be in nearby the door itself. It shouldn't be more than like 3 feet away, but there is also a rule for that. So normally you should use a different bit for the acknowledge from a door. Okay, so now we do need the queue. What do we do for the queue? I think you already know. We go to the Datablock for safe Estop door, and we put the door KF12 in there. Okay, make it a bool, copy it. No, we don't copy it, we drag and drop it. No, we don't drag and drop it. Go back here, and then if we start typing the name of the DB, it will automatically appear. So it's the safe Estop door, and then there is the dot, and then after the dot in the next level you'll find the bits, and then we can just choose this one here. So for the next thing, I do think that you know what we're gonna do. We will be adding this input, this door safety to the output. Copy that output from the door, put it in here, download it. So what do we have? The door is what? Is the door open or closed? So the input is true. that means the door is closed, and if we acknowledge it, the door is open, and we will also see the door is closed, and we will also have the closed contact here. And if I make this a little bit smaller, we can see the whole thing on one screen. So let's go ahead again and open the door. I just simulate this with an Estop. Input is off, close the door, input is on. Check that your area is free of people, that there is nobody present anymore. And if nobody is present, you push the acknowledge. The door is actually now also acknowledged, and your output is okay, and you can run a motor or whatever you want to do with it. And I was happy to show you the Estop function and the door function, and that video is I don't know how long already. I'm sorry for that long video. I'm just trying to give you as much knowledge as possible. So see you in the next video, and this was the video about Estop and safety doors using a Safe CPU 1515F from Siemens with the TIA portal. Thank you for watching, and bye bye.